Welcome to another GCBASIC tutorial for the PIC18FxQ35 chip family. This is sequencing the LEDs. Let's just see the cowl come together. There we go. We should just wait until that happens. Whilst that's coming together, don't forget to like the video and subscribe to the channel. All the metrics help. Like and subscribe. Okay, this is sequence number 4. Sequence the LEDs with a delay using the value of an ADC read. Let's just do it, okay? All right. It's really quite good. I am using a PICDEM 2 plus demonstration board, very old board. I'm using a 5K pot for the analog input and 4 LEDs connected to port B. Let's look at this. What I've got here. These 4 LEDs, that's where we left it yesterday. Let me just see if that's still working. I've been doing all the stuff, by the way. That's where we left it yesterday, where the LED are representing the value of the ADC. And what else have I got? That's it. And that 4 LEDs and an ADC, so I'm done. The circuit looks like this. Come back to the desktop and show you that. But we'll zoom in on that in a moment to show you that circuit anyway. So, we saw this before, analog to digital, GCBASIC completes an initialization process for you. You can put the return values into a variable. It then does the ADC, so it makes it really easy to make it work. So a read AD, we saw one yesterday of 0 to 255. This one is going to be a read AD 10, which reads 10-bit number 4096. So then I'm going to introduce you to this wait command for a time period based upon the return value of the ADC, and then we'll do it all again. So what it looks like in terms of the circuit, 4 LEDs connected to the PCB, RB0 to RB3 via suitable resistors. I have a 5K potentiometer connected to VDD, which in this case is 5 volts, so a suitable resistor, current limiting resistor to RA0. So I'm going to be using the RA0 ADC, which is called ANA0. So the code I might have to change, but that's just a constant. So what we're going to be doing is looking at a thing called we're going to look at wait in particular for a moment. And wait in GCBASIC creates a software loop. Therefore, you don't need to do a timer. You can still use timers, don't get me wrong, but this is just very simple for a simple calculated loop, and it will do that based upon the PIC's instruction cycle, which is basically the oscillator divided by 4. Changing the oscillator frequency changes the instruction timings to calculate a wait. Recalculating that loop keeps the accuracy of your delays. If your oscillator configuration doesn't match the real hardware clock, the wait delays will be either too fast or too slow. First place to look, if you go wait 1 second and it waits 2 seconds, just go check the frequency. So this tutorial is going to pull together using the ADC and this wait to sort of figure out how long it should wait rather than just do a fixed delay. So we're going to initialize the chip, set the first LED, read the ADC, and then wait for a delay based upon that, rotate the LEDs, and did it overflow? If it didn't overflow, do it all again, and when it does overflow, go back and set the first LED. Pretty simple. But what we're also going to do is we're going to check the carry flag. Now, in GCBASIC, it doesn't matter what your chip is, it's called C. But it does this. We are going to move the bits of a register, I believe, to the right. So we're going to put a value, and by turning on the first LED, once we do a rotate, it will move that, slide that to the right, and therefore the next LED will turn on. Shift again, the next LED. Shift again, the next LED. But if I shift once more, it sets the carry flag. Therefore, I need to restart. And once I know that I've set the carry flag, I can reset, go back, and then restart my whole process exactly as before. The carry flag does that. Do that again. Starts LED 4. The LED numbers are wrong. Doesn't matter. Look at the red. It's moving it, moving it. The carry flag is set. Once the carry flag is set, we go back to the beginning and then repeat the process. So it looks like that. Did it overflow? And it's C, called C. I'm also going to use scale. Scale is something we took from Arduino, and it scales an existing value between a start value, in this case, the minimum of the ADC to the maximum of the ADC, and we're going to scale that to another value so that the LED looks nice. To have a zero weight, it just doesn't work. So you can we'll look at that. You can scale an input number to an output number. I believe we're going to scale the output to 50 milliseconds to 1000 milliseconds. So we're going to look at a lot. We're going to read the ADCs to set the LED. We're going to use different variables. We've only used a word so far. We're going to use some simple logic, rotate. We're going to do some masking, and we're going to do some scaling. So it's quite a complex piece of code, but it does show some of the capabilities. So I'm just going to close down my IDE here, get rid of everything that was open, and I'm going to restart it because you can see what happens. So GC Studio, and it will take me into GC Studio. You've seen this before, and my folder that I'm looking at here is the 18F folder, and I can just take it from my recents now, and it will take me directly into the IDE. This bottom panel is called the terminal. It opens up sometimes. You just need to shut it down if you're not using it. Control B to open up the Explorer window. We want 060 variable rotate the LEDs. We have it in the editor now. It's in italics. There's no red dot against it. So, because if the moment I make it dirty, I get a red dot to say I've got a dirty file, and you should save it. Control B will shut down the Explorer window. Other ways of getting to that, that's my way. So let's look at this code. We start with specifying the chip, and we're saying option explicit, so that would ensure that we define our variables and that all our constants real. Okay. We've seen this before. We've seen all this before. So look, we've seen define the constants for the LEDs, set them as outputs, set another constant, don't know why. Define the potentiometer. Not really necessary, to be quite frank. But here we go. This is specific to this program. We're going to put the ADC value in a word variable. Therefore, that has a range of 0 to 65535. So there's a range. We're all going to also have a variable that represents the value of the LED port state. We're going to play with that piece of RAM. It's a piece of RAM. So the first thing we're going to do is we're going to set one port on. So we set LED port to there. And if you look at this, it actually sets the fifth one. Is it the fifth one? Maybe that should be the fourth one. I think that should be the fourth one, which is that LED there, isn't it? Yeah, that's better. We'll do that one. Okay, we've got a do loop. This is the whole program. Here's the do loop. There, look. I'll just click it. You can see it. I go read AD10. We know from our previous one, that's an a 0, and that's a constant, and that has a value of 0. And you can look in the CDF file for that definition. So this can return values up to this number. And so once we've got it back here in ADC value, because that will set everything up for you, we're going to say the range of that is 0 to 123 and scale that to 100 to 500. I said 1000 in my documentation, so I should put that to 1000. So what we're doing, we're taking the ADC value, putting it in ADC val, and then we're scaling that to a meaningful number. And in here, I say wait for the ADC value. So rather than use a constant like the number 1, we're using a word variable. And if you want to have a little play, all right, you can play with this. You can take out the scale and just try it, and you'll see what I mean by when you have a weight of 0. It doesn't make any sense to anybody. Okay, now we're going to do some rotational stuff. So the first thing we want to do is just clear the carry. because that can be set by lots of different things. For our operation, in this instance, at this moment in time, we need to clear the carry. And then we're going to rotate the LED port state to the right. That means we're going to shift all the bits along. Okay, job done. Move them along. Now, if the carry state is set to 1, if the carry register is 1, reset the LEDs. Now, there's lots of ways of doing this. Okay, I've set the bit lock. I've said LED port state bit 3. Oh, you can address bits inside of registers and variables. Very clever. You can set it to 0 or 1, therefore. There you go. So if it's carried, we'll set that LED back on. Otherwise, and then what we then do is say, right, we'll set the port to a value, and we're going to throw away anything in that's extraneous to what we need. We'll say LED port state and the 4 LEDs with the 4 bits that we're interested in, and mask, because you have different masks. So you could actually, to be quite frank, you could add that with port 0, port B itself. If you're using some of the other bits, it sort of works. So that's how we set the port, and then it goes back to the top of the do loop, reads the ADC again, scales it, waits, clears the carry, rotates one more. Function key F5 to program it. Look at that, look. That's because I've been playing and doing other work. In Edit Preferences, into the Press tool, second tab, change it to pick GCBASIC. GCBASIC is the GCBASIC assembler. We're just waiting for Microchip to give us a version that works. Okay, reset that size, say OK, and I've just changed the assembler by doing that. Go back to the desktop, function key F5, and it will compile it. So you've seen what was called an error, but it's not. It was quite a nice error. And now it's programming it. And has it done it? I've probably done it already. I'm not that fast. The LEDs are rotating. Why are they rotating? Because if I rotate this, the reason I chose 50 milliseconds is hopefully you can still see those LEDs rotating. If I rotate it, it will go to 1 second per LED rotation. And back. So that tells us, by the way, that we know that that ADC is returning its correct values because that scaling is correct. Look, 1 second, 1 second. If it wasn't coming back at the correct value, it wouldn't be 1 second, but it is. Later on, we could put the ADC values on that LDC, and we can see the ADC values. We may do that later on. So what we've seen there is a 10-bit read of the ADC, scaled it out between 100 milliseconds. I said 50 milliseconds in the PowerPoint. Put that to 50 seconds. So it comes in at this value, and then we reset it to that value. Wait for so many milliseconds, and then we do the carry, clear the carry, rotate the variable, check the carry, and then set the LEDs. Rotational works fantastic. Let me just bring that up. I am going to press function key F5 to reprogram it. And I just changed that to 50 milliseconds, if you remember. So the minimum now is 50 milliseconds, which might be a little bit too fast for the camera. There we go. I think it is too fast for the camera, but there you go. So we're using the internal oscillator, and we could change the internal oscillator, as I've shown you previously, the frequency of it, and it will work still. So let's look at what frequency it's running at. It's running at, on the internal oscillator, at 64 megahertz, which is perfect. We've got at the bottom of this code the optimization code that I showed you yesterday in the previous tutorial. So it has been optimized. It's sort of throwing some of the code out. Now, you can do an ADC read in assembly. You can do it lots of different ways. This is a utility. Think of this as being a utility method. If you wanted the fastest, you could just take the code that we've generated and just get rid of the rest, okay? just do the register changes. The same with scale. Scale is a utility. It's a huge piece of code. Arduino wanted it. Someone, we implemented it because someone was asking for it, and we did it. Look, is it huge? Absolutely. It's a lot easier to do it in maths, to be quite frank. Scale is not optimized, and you can literally take that number and do it a lot quicker in simple maths, to be quite frank. But scale is a utility. The rest of this is not a utility. This is very close to the ASM, and if we looked at the assembly that's been produced here, we would see it's using the command rotate for this specific chip. Great. Tutorial done. Let's get out of here. Seen enough today. Back to PowerPoint. Okay, now what we're going to do next, we're going to use an input to set the state of the LEDs. So we've really done output so far, done ADCs, bit of weight, word and variables, all this stuff like that. But now we're going to get to the input side of being able to change the input to change the state of the LEDs. And this all makes sense because this is a really good test that you understand how the architecture works. Part 4, sequence the LEDs. Enjoy.